Start streaming. And yeah, in an earlier class, I was just trying to teach my mobile app programming class. One person was trying to use recipe.com for a basic recipe, but then the app would actually be able to scale the recipe for like 2 people, 4 people, just recalculate all the amounts and then bring up and then create its own shopping list. So that's what he was doing, and so I had to help him figure out how to decode an HTML document into its components so that he can actually locate the actual recipe part and the quantity part relatively easily. So that's what this stuff is. We were testing some JavaScript code on the Power server, so that's kind of cool. Pretty sure the cybersecurity discussion will call this, "Oh, you're hacking," but not cracking yet. All right, so we'll get back to this class. And today we're going to start on, well, okay, we'll finish the last topic first. And let's see, where is this class? All right. So what we're doing is we're finishing up this class, this topic using the Dijkstra and the A-star algorithm. The homework assignment is on Dijkstra's algorithm, okay? Um, well, at least this one is. There may be another one later, right? Okay, so the assignment looks like this. Okay, I give you the graph, I give you the vertices, the edges, but in the form of 2 sets. Okay, so you have to kind of draw the picture and then kind of get a visual view of what it looks like. The distance function, once again, is also expressed as a set. Okay, that was intentional. Okay, because I know I could have used like d of AB is 1, d of AD is 10, and so on, or just have the distances reflected on the edges in a graphical form. But I want to give you this representation instead, just to make sure that you know that there's correlation between what we are talking about now, and it relates all the way back to all the set theory stuff that we have talked about at the very beginning of the semester. So I just want to make that connection and make sure that you guys understand that connection too. So here's a spreadsheet, which is an example of a trace. So this one is definitely not for the graph that you're going to have to solve, but it is an example. Okay, so I want you to use this particular format to kind of go through the trace, which is very similar to what we did in class for the A-star algorithm, and I think we did one for Dijkstra's algorithm as well. Okay, so use this as a template and then just work with it. And what you need to turn in is a spreadsheet kind of like this, but specific to solving the problem that is in the assignment. So are we good so far with, in terms of, what you need to do for this homework assignment? Okay. So I don't think it's going to be too hard. It's mostly just, following the algorithm, tracing it, putting it into a spreadsheet and stuff like that. And you have 1 week to work on it. It's due next Wednesday at noontime. So I think that should be enough time. But I would still work on it, get started with this early, just in case you run into any problem, any questions, you can still ask those questions on next Monday, and we can talk about that. So are we okay so far with Dijkstra's algorithm and also A-star algorithm? Yes?
So you just wanted us to trace it on a Google Sheet?
Yeah. Yep. Have your own Google Sheet, but borrow the column heading of this document, and then borrow the way that I do the tracing.
Okay.
Yep. So it shouldn't take too long because the graph that you have to solve only has 4 vertices. It cannot be that bad. All right. Shall we move on to new topics? Okay. So the new topic we are going to start on today is on predicate calculus. I rearranged the modules a little bit, so now it's actually in the correct order for this particular semester. So predicate calculus is kind of fun. Okay, no, I take it back. predicate calculus is very boring as a topic, but we're going to apply it in a way that is fun. So we're going to do this using Prolog. Okay, we're going to do this using Prolog. Prolog. This is not a misspell of the word prologue, because some people may argue and say, oh, that's it's G-U-E as the last three letters of Prolog. But this is the name of a programming language, Prolog, and it does not have U-E at the end. Because I think Prolog was invented in France, okay? So it's not even, quote unquote English. It is actually, I guess, the French way of, spelling Prolog. So it's a predicate calculus engine which allows you to enter predicates and also rules, and then the engine itself will try to do the reasoning for you based on what you have entered. Okay. So what we'll do is we're going to get started with Prolog first, and then we'll get back and talk about what is predicate calculus or what is a predicate. So the syntax of Prolog is discussed here. Oh, well, might as well we'll talk a little bit about the history of Prolog. So we'll go through the introduction here. Prolog was an artificial intelligence programming language for quote-unquote reasoning, and it was not really used that much in the United States, but it was used a lot by European countries as well as the Japanese back in the mid-'80s to the late '80s. So we are talking about a fairly old programming language for certain types of AI application. This is kind of the counterpart of neural nets. Neural nets are very good with non-symbolic stuff, okay? Image processing, sound processing, voice recognition, okay? That sort of stuff. Prolog and to a certain extent Lisp are symbolic processing programming languages, and they excel at certain things like finding, applying logic, applying rules, inferencing, okay, deducing. That sort of stuff, is what we need Prolog for back in those days. The basis of Prolog, the programming language, is based on predicate calculus, which is something that we have to talk about in this class. It's on the curriculum. But instead of just talking about predicate calculus in theory, we're going to apply it in Prolog, because now you can actually see predicate calculus in action. Okay, we couldn't quite do that with propositional logic because there are no commercial, propositional logic, reasoning systems other than the one that you wrote for yourself. So the syntax of Prolog is kind of interesting. Unlike most other programming languages, not only is Prolog case sensitive, but the case of the first letter of a word actually has meaning to the programming language. So it's not really just a convention that variable names start with a lowercase in C, C++, Java, and most modern programming languages. In Prolog, it actually has a meaning. Okay? If a particular word starts with a lowercase, then it is basically identifying what we call an atom or a function. Okay? I'll talk about what an atom is later on. It can be the name of a predicate or the name of an atom. Okay? If it starts with the uppercase, then it is known as a variable. Okay, so what is a variable? Do you guys still remember quantifiers, for all, there exists, that sort of stuff? Okay? Whatever you're quantifying is a variable. That's the bottom line. Okay? So that means in Prolog, if you start a word with the uppercase, you're already implicitly using a quantifier. Now, which quantifier out of the two? We'll get to that later. Okay? We'll get to that in just a little bit. So a predicate calculus system logically represents the truth of a particular universe. The universe, okay, so the other term is called the domain of discourse, or the universe. It's a set of all the things that you're interested in. Okay, so it depends on what you want to deal with, right? So if you want to write a Prolog program to deal with ancestry, okay, then the ancestors, people become the atom. And each person becomes an atom, and collectively, every single person that is in the system will now comprise the quote-unquote universe. Is that okay? All right. And other types of systems may want to deal with numbers. and yet others may want to deal with like medical stuff. So then each type of virus becomes an atom. Each type of medication becomes an atom. Each type of characteristic of a patient becomes an atom as well. So it is typical that we use the uppercase U to represent the universe. So a predicate itself, okay, so if we have a predicate P, it is conceptually a function that maps a tuple of elements of the universe to either true or false. So we'll take a look at this kind of awkward looking representation. It describes a function, okay? This is a representation that we have used since pretty much maybe the third week of the class. So P is the name of the function. The colon says, okay, the following tells us what kind of domain we're dealing with and what kind of codomain we're dealing with here. The domain is this, and then the codomain is this part. The codomain is simple, right? It's 0 or 1, which is basically, in this class, that's how we represent true, false. Okay, 0 is false, 1 is true. So it is mapping something from the domain to just true or false. What kind of stuff are we talking about? We are basically looking at a Cartesian product. I borrowed the pi symbol here for quote-unquote multiplication, which is what we use a Cartesian product for. So it is just multiplying k plus 1 times in this case. So it all depends on, in this representation, k is actually incorrect. That should be k plus 1. If k is the length of the tuple, then the pi should end with k minus 1 and not with k. So I'm off by 1 there. But the idea is still the same, okay? It's a function of u times u times u times u times u, and then it maps that domain to the codomain of either just true or false. Is that okay? I'll give you an example, okay? Let's use an example where the universe is the ARC campus. We're concerned about things or people on this campus. Yes?
I was just going to ask, so is it like the reason why you have that tuple there is if you have like px or pxy or like pxy, like you have multiple arguments?
Right, because a predicate can use any number of arguments, including 0, okay? So that's why we just generalize it to k.
Okay.
Yep. Okay, so if you're concerned about the campus, okay, or people on this campus, then each individual on this campus becomes an atom, and all the atoms put into a set would now become our quote-unquote universe. Is that okay? So what is a predicate that is applicable when the universe would be all the people on this campus? Well, we can express quote-unquote relationships, okay? So you can now have a 2-variable predicate that says, X is the teacher or professor of Y, okay? Is that okay? So that function can be defined across universe times universe, because occasionally, some professors may decide to take classes from other professors too, okay? So that becomes, the function that we are talking about, or the predicate that we are talking about. This is just an example. In other words, any function that maps tuples of the universe, each item is an element in the universe, to true, false, is what we call a predicate. Do we have any questions about that part? Yep.
Earlier you said variables are quantified, but atoms are not quantified.
That is correct, because atoms represent individual things. You do not need to quantify individual things. The only time you need to quantify is when you use a variable. Okay, I'll give you an example. When you say Tak is a bad teacher, okay, it's a predicate. But it's a predicate that is only, okay, I take it back. Is a bad teacher, X is a bad teacher, is a predicate. Because it has a variable X, right? And it maps the predicate to either true or false. But who can be that X, right? Well, it's anything that is in the universe. So on this campus, anyone can be that X. Not only professors, okay? Even students can substitute into that X. But students are not professors to begin with, so they cannot be bad professors. Is that okay? So so tag as an atom, you don't need to apply quantifiers because we're talking about a particular individual, or Professor Fox, okay, is an individual. You do not apply a quantifier to that. Now, when you apply quantifiers, that's when you say for all or there exist, okay. For instance, if we say, all math professors are superb, okay, then you're saying, for all, okay, for all x, now x is a variable because x can bind to anything within the universe, okay? So you say for all x, in parentheses, you specify, x is a math professor and implies, x is a good professor. So that x is now a variable because, exactly which professor are we talking about? We don't know. We're only, expressing a truth of, if someone is teaching math, that person is automatically a good professor. So that is the application of the quantifier because it makes a big difference whether we say for there exist or for all. If we say, there exist, x such that, x is a math professor implies x is a good professor, then we're only saying that there's at least one case where that person is a math professor and also is also a good professor. Take it back. There's only one, at least one thing in the universe satisfies that requirement: the implication itself. So we'll get started here with something. This is a predicate, or this is a what we call is a rule. Okay, so a rule in Prolog is not necessarily a predicate, but it expresses a truth. So in this case, this is how we say Luke Skywalker is a Jedi. Okay, and if this is in the system, it means it is true. So we are basically stating everything that is true. So it is true that Luke Skywalker is a Jedi. Is a Jedi is the name of the predicate, and then Luke Skywalker, starting with a lowercase l, is the name of an atom. This is how we identify a particular atom in this particular universe. Is that okay? All right. But what we see here, okay, this part here with a period at the end, is really a short form of this form here. Now, how do we read this? This actually is saying, it is not saying that, technically, it is not saying that Luke is a Skywalker is true. It is really saying true implies Luke Skywalker is a Jedi. That is what it's saying. In other words, when you have a rule that is in this general form, whatever is to the right-hand side specifies the condition that implies whatever the left-hand side is trying to specify, which is really awkward and counterintuitive from our perspective, because the way we use implication is the implication goes from left to right. Whatever is on the left-hand side implies the right-hand side when we use the double bar arrow thing. But in Prolog, it's exactly the opposite. Okay, whatever is on the right-hand side of this symbol, the colon dash, is implying whatever is on the left-hand side. So what can you say about true implies Luke Skywalker is a Jedi? What do we know about Luke Skywalker being a Jedi? Is that true or false? Because the left-hand side, or it's implied by true, so that means whatever it is implying has to be true. So are we okay with this particular rule? So the rest of this is really just spelling out everything in words, so I can write it down. So the rules are the basis of all the truth to be derived. So now we can start with something that has variables like this. Okay, so we are looking at this particular rule. So first of all, we want to learn how to read this rule. Okay, what is being implied by what else, and what about those commas? What do they mean? So the way that we interpret this particular rule in Prolog is if X is a Jedi and a comma is representing and, okay, A and X owns Y, and Y is a lightsaber, the entire thing here, which is the huge conjunction in this case, implies X is a proper Jedi. That is what it's saying. So if Luke Skywalker, before he owned a lightsaber, he would not be a proper Jedi. He might be called a Jedi, but he's not a proper Jedi. Any Jedi who has lost his or her lightsaber is not a proper Jedi. You may be a Jedi, but you're not proper. Is that okay? So let me just say that one more time, how to read this particular rule. Whatever is on the right-hand side is X is a Jedi, and X owns Y, and Y is a lightsaber, implies that X is a proper Jedi. Okay, but Tech, you did mention something about, anything that starts with the uppercase, X and Y in this case, are variables, and every variable is tied to a particular quantifier. So we'll talk about that after I answer this question. Go ahead.
Does the order on the right matter?
Yes, it does. So the ordering of whatever is to the right-hand side actually does is. So in logic, it is not important because conjunction is commutative. But in terms of the program, it is actually important because it does evaluate it from left to right guaranteed, and it will try to find something that meets this requirement. So it will first try, okay, let's see what happens when we substitute X with Luke Skywalker, because Luke Skywalker is a Jedi, right? Then it will try to find what Luke owns, and then it will try to figure out whether that's something that Luke owns is a lightsaber or not. If any one of these fails, it will quote unquote backtrack and try something else. So it will. So if okay, so let's say Luke Skywalker owns. He doesn't own R2D2. What does he own? CP3O? No, CP3O is. Does Luke own CP3O? It will pass down to him, right? What does he actually own? He was a farm boy. Speeder. Okay, so we'll say that Luke Skywalker owns a particular speed racer. Okay, speeder. But a speeder is not a lightsaber, right? So what Prolog is going to do is it will go through all the things that are known to be Jedis. So let's say Luke Skywalker is one of those. So we'll try to say, okay, let's see what happens when we substitute X with Luke Skywalker. Okay, then we'll move on to the next step and say, what does Luke own? Luke owns a few things. Luke owns a speeder, and then it was check. Okay, but is a speeder a lightsaber? The answer is no. We cannot confirm it. Anything that cannot be confirmed to be true is automatically false. So speeder is not a lightsaber. Okay, fine. We backtrack then back to here and ask the question, what else does Luke own? Then it will look up and go like, oh, Luke owns this thing here. And is it a lightsaber? Yes. So once it satisfies all the requirements, then it will imply whatever is to the left-hand side of the implication symbol here. Then it will confirm that X is a proper Jedi. Now, X being a proper Jedi may be utilized as a component of another rule. So all of these can nest in an interesting way. Yep.
Will it go through every possible X in that case?
It does. It will go through every X. It will go through everything that is known to be a Jedi. So it's not going through every single thing in the universe. It will only go through the things in the universe where that thing is a Jedi is confirmed.
But it will check to see if everything is a Jedi. And once it finds out that it's not, it just goes to the next.
Correct. Yeah, you can kind of think of it that way. Yep. All right, so getting back to the quantifier, because every variable is quantified. So now the question is, which quantifier are we using here? Are we using for all there exist? What about X and what about Y? Okay, so we have to look at this and figure out X is different from Y in a very important way. X only appears on the left-hand side. So variables that only appear, excuse me, any variable, okay, I'm taking back what I said. X appears on both sides, but it appears on the left-hand side. Okay, that makes it special. Any variable that appears on the left-hand side are universally quantified. In other words, we apply for all to those things. What about y? Y does not appear on the left-hand side. It only appears on the right-hand side. So if you have a variable that does not appear on the left-hand side, but it does appear on the right-hand side only, that becomes existentially quantified. In other words, we apply there exist. Okay? So let's apply that and see whether it makes sense or not. So the way to we're going to read this rule is we say for all x in the universe, okay? If and there exists y, x is a Jedi, x owns y, and y is a lightsaber, implies x is a proper Jedi. In other words, we only need Luke Skywalker to own at least one thing, that is a lightsaber. What if Luke is a hoarder and he has 20 lightsabers in his safe? He'll still a proper Jedi. We just need one. Yep.
So you're still going to read it from left to right, but you have to backtrack to...
If you cannot make something true, then you have to backtrack and try something else. So are we okay with this rule? Do we know how to read this particular rule? It's kind of cool, right? Yep.
On the right-hand side,
Mm-hmm.
within your parentheses, are you going to have more than just two variables at a time sometimes?
On the right-hand side, you can have any number of variables on both the left-hand side and the right-hand side. But if you have variables on the left-hand side, those are universally quantified. They're all for all, okay? But if you have a variable that only appears on the right-hand side, that is using the existential or there exist quantifier. Is that okay? Are we good? Okay. So the rest of the next few paragraphs are really talking about the same thing. So if we put these rules in, then when we ask, who is a proper Jedi, then the system will automatically figure out and say, oh, Luke Skywalker is a proper Jedi. So I think this is a good time to actually demonstrate, and kind of work with Prolog. It's kind of fun. All right, so or did I turn on the, yep, I did. Okay, the recorder is on, so that's good. All right. So the first thing we need to do in Debian, I just entered the wrong password, is to install Prolog. And this is why, oh, okay, I got another configuration window open somewhere. Okay, we'll kill those first, then we get this one, and then we look for SPI Prolog. And let's see, SWI. There we go. And to install it, I just click a plus sign when it's on that item. This is in Aptitude, which is a package manager. And press G to start the process. And that will get it installed. All right. So you guys may think, but what about those people who are using Windows? Well, it's okay because SWI Prolog also has a Windows port. So you can just download it, install it on your own machine, and run it and play with it. Okay. All right. So now we need to go back to the command prompt here, and we'll go ahead and enter a program. So we'll do something that's simple first. So I will call this program Jedi dot Star Wars dot. It needs a particular extension. I think it's PL for Prolog. There we go. So now you can just type the program in. So we are only concerned about is a Jedi first. So is a Jedi, Luke Skywalker. I'll just say Luke S, okay, because there are no other Lukes in that particular franchise. So Luke is fine. Luke S is fine. Is a Jedi. Yoda is a Jedi. So who is not a proper Jedi? Who is kind of like Jedi-ish but does not have a lightsaber? Hmm? Who? Who? Han Solo. Hmm? Who? Leia. Okay. Okay, Leia, and her last name is O, right? Yep. Okay, Leia O. Okay. So the first thing we'll do is we're going to save this and just see how we can run SWI prologue to get this to work. So when you're in prologue, I think you use a square bracket and then you specify the name of the file but without the extension to bring the file in. And you have a period after each sentence. So it's kind of picky about the syntax. You have to end every sentence with a period in order for it to work. So when it returns true, it is telling you that it has incorporated all the rules in that file. Okay? So now you can ask questions. You can say, is a Jedi Han Solo? Now, if you do this in other programming languages, it would probably complain and say, well, there's no such element Han Solo. It was never mentioned anywhere. But in Prolog, it's okay. Okay, you can introduce new elements in the universe as you see fit. Okay, but this is a question. It is not a statement now. It's in query mode. It is a statement. It is telling you that Han Solo is a Jedi. It's false. It's false. There's no confirmation that he's a Jedi. Remember, anything that cannot be confirmed true is implicitly false. Okay? Yep.
Did you say that variables were uppercase for the first time?
Yes. Variables have to start with uppercase, and names of atoms and predicates and functions, they have to start with lowercase. Anything other than variables have to start with lowercase, basically. Okay, so now we can ask another type of question, which is a Jedi? And we'll say, tell me who is a Jedi. I'm not confirming whether a particular atom is a Jedi. I'm asking, tell me who is a Jedi. Tell me about all the Jedis. Okay, so you press the Enter key, and it's waiting for you to press a key to go to the next one. And I cannot remember which key. I'm going to try space. Yep, that's it. That's it. So now it's telling you all of the Jedis. Okay, Luke is confirmed a Jedi. Yoda is confirmed a Jedi, and Leia is also confirmed a Jedi. Yes.
So it knows that it's all based on the fact that the X is capital?
Yes. Now, if you turn that X into lowercase x, then it will tell you that lowercase x as an atom is not a Jedi. See how it is case sensitive in a very weird way? So are we doing okay so far with this example? Yep.
When you queried it with Han Solo, does it actually add that to the universe? Like, could you try and do not is a Jedi and get Han Solo back?
Now, that is the question. How do you confirm something is false? Okay, so the negation thing is going to be discussed later on in the notes, but right now we are not concerned about negation.
But does it actually, when you type it into the prompt, does it add Han Solo to the universe?
I'm guessing that is the case. Yep. All right, so this is our first try, with a Prolog program. Okay, but it's already illustrating a rather interesting aspect of Prolog. Is it can figure out, you can give it unknowns in a query, and it will try to answer the question by, telling you, by substituting this unknown with that, you can make that predicate true. So it's a problem solver. It's not really just running an algorithm. It has its own engine of trying to find out what is true and what is not. Okay, so let's switch back to the notes here. And let's see, where were we? There we go. All right, so section 4 is kind of like a segue into a discussion of substitution. And basically how it works, okay? Internal to the Prolog engine, how does it find all of these answers, okay? So the first thing we do is we are rewriting that rule that we have presented earlier in the kind of more of the terms that we are familiar with. So let me zoom out a little bit so you can actually see the entire thing. There we go. So I'm just going to click on it and basically point out how this is expressing. Oh, I can't display both at the same time, can I? I have to zoom out one more time to do it. But that's fine. Okay. So what is highlighted here is the usual logic representation or Boolean representation of this particular rule in Prolog. Do you see how x is using a universal quantifier? For all x in the universe and for all, there exists a y in the universe. So I don't need y to be universally quantified. I just need at least one y that can make the following true. What do I want to make true? X is a Jedi, X owns Y, and Y is a lightsaber, implies that X is a proper Jedi. Is that okay? So do we have any questions about this? Yep.
So like the order of those quantifiers, is it just like which one it hits first? As it like
The quantifiers. You mean X and Y?
yeah.
What about that?
How does it know which one is first and which one's second? When it like
We always do the universal quantifiers on variables appearing on the left-hand side of a rule first, and then the existential is always inside, nested in the inside.
okay, so it just goes from for all to for some like
Yep. Yep.
so for like the for all to like say it had multiple, how would it know which for all comes first?
In that case, it would not matter in which order because they're all universal, right? So if they're all universal, then you can say for all x, for all z, or for all z, for all x. It doesn't really matter. Because in that case, you're basically saying for all ways of pairing x and y, and x both have to be coming from the universe. So it doesn't really matter what order that you specify. But the existential has to be inside, I think. Yeah, it makes sense it's in the inside because you have, by the time we get to this part here, we have already bound x to one of the elements of U, and then we're asking the question, for this particular thing in U, do we find at least one y also in U to make the following true? So are we still doing okay so far with this? So this part is nothing new. It's just it's just another representation to specify this particular rule in Prolog in a kind of more mathematical equation way. Yep.
So does that mean, based on that hypothetically, will it check if the lightsabers are Jedi?
Whether it would check.
The things that qualify for Y would also qualify for X. So it would check if, say, the lightsabers are Jedis.
It will check that. Yes. So if you have a lightsaber, of a particular name, it will bind that lightsaber in X place. But since a lightsaber is not gonna be confirmed as a Jedi, so that will basically just fail this condition. Then you have to go back and look for another thing in the universe. So are we good so far? Okay. So we can also kind of look at this as, this is the phi, because it's an implication. Let's see here. So we look at phi as the entire implication, but without the quantifier. Okay, so this is phi. And the way Prolog, the engine, the way it works is it works by substitution. So we're going to use, substitution like this. A substitution, in this case, the substitution itself is known as lowercase s. A substitution consists of elements, and each element is, let's see, there's a particular name for that. I just want to make sure I'm using the right name. A mapping. Okay, so each item in the set is a mapping. So in this case, it's mapping variable x to the specific atom of Luke Skywalker. It is substituting y, which is another variable, with the specific name of an atom, which is Anakin Blue, because Anakin owns a blue lightsaber, so I call it Anakin Blue. So that specifies in substitution. So are there any questions about the concept of a substitution? Each element of a substitution is a set. Each element in the substitution set is a mapping. It tells you, oh, let's go ahead and change this into this. And then another element can tell you, let's change that into that, and so on. Is that okay? So what do we do with substitutions? We apply substitutions to statements. So the application of a substitution is expressed kind of like this, in a very boring form. Phi s, basically means we are applying the substitution s to the statement phi. Okay, so when you spell it out, what are we doing? We are looking at this phi, okay, and then we are applying this substitution, which is basically saying search and replace. It's basically saying search and replace every single uppercase X with Luke Skywalker. Search and replace every single Y with Anakin Blue. That's what substitution is saying. So after the substitution, this is the result of the substitution. The result of the substitution is Luke Skywalker is a Jedi. Luke Skywalker owns Anakin Blue, and Anakin Blue is a lightsaber, implies Luke is a proper Jedi. That is the final result of the substitution. Well, but is it confirming this thing is true or not? Nope, it's not confirming anything. All it is doing is to give you a resulting statement which may be true or false. Then you have to look into this and say, well, can we confirm that Luke Skywalker is a Jedi? Yes, okay. Do we have another rule that says Luke Skywalker owns Anakin Blue? Maybe, maybe not. If this is missing, it is not confirmed, then this entire thing is not going to work. I mean, it will still be true because this is the first part is false. When you have an implication, if the first part is false, the whole thing is true. So it will still be a true implication, but it's not going to be very useful because we could not confirm that Luke is a proper Jedi. Is that okay? So you can kind of imagine if your universe is really big, then we can potentially have a lot of different substitutions that are applicable to a particular statement. And Prolog has the engine to try all the possible combinations. And that's why it can find the answer for you. Yep.
Is that notation for like this prologue use a notation like that for substitution, or is that just for us to describe it?
This is for us to describe it. The substitution mechanism is hidden from you. As a result, you cannot specify the substitution mechanism. It's just how it works behind the scenes. Okay, all right. So let's go ahead and put in something like this. We'll put in the rules for is a proper Jedi and who owns what and so on. Okay, so let's go back to our terminal and make some further changes to it. So now we want to specify ownership, right? So Luke as owns a shovel A. I mean, he does grow up in the farm, right? I mean, having Luke to own a shovel is probably not far-fetched. And I think he owns all kinds of various tools to repair robots, right? So we'll say screwdriver A. But he also owns that lightsaber, so which is called Anakin. How do you spell Anakin? A-N-A, Anakin Blue. Okay. But we also know that only one of these three is a lightsaber. Is Anakin Blue. Now you can add additional predicates to tell people what a screwdriver is or what a shovel is and so on, but we are not going to do that, okay, because it's not really adding to our discussion. And then we'll specify that rule that we were talking about a little bit earlier is a proper Jedi X is implied by, okay, you can when you look at this symbol, instead of reminding you of, oh, it is implied but it's backwards, you can also just think of it as it's implied by or only if. Okay, those are equivalent ways of saying it in logic. So you can now say X is a proper Jedi only if blah 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 blah. Okay, so that blah 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 is going to be Luke. X has to be a Jedi first, and X has to own a something. So X owns Y, and this Y that X owns has to be a lightsaber, which is basically the same rule that we looked at earlier in the notes. So now I'm specifying this rule here. So everything before this line, there are rules that specifies exactly how a particular atom relates to another atom. But this one does not. It's a proper Jedi is a rule that says, hey, anything that fits this requirement is a proper Jedi. That's what it's saying. Are we good so far? Okay. So now we can save the file, go back into Prolog, read the file back, Star Wars, and then we can give it a try. Okay. So the first thing we try is a proper Jedi, and we'll try Leia first. And it says no. Okay, good. And then we can try the other one that we tried earlier, which is to tell me everyone who is a proper Jedi. And it will say Luke is the only proper Jedi. There are no other proper Jedis in this case. Because not everything in the atom is a proper Jedi. It will only return true if everything in the universe is a proper Jedi. Yep.
Will it let you do things like one like P implies B kind of stuff?
P implies B.
Like a predicate implies itself. It's like true, but would that
Like a recursive predicate? Yeah, it would. So your homework assignment would actually involve something like that. So I'm not gonna. So when you do have recursive predicates, then you have to lay out the ground one first, because otherwise it will end up going into endless recursion.
So like first in the list of like.
Yep. Because you can specify alternative ways to make a predicate true, but the grounded ones, the non-recursive ones, have to be listed first, because the evaluation, which one it picks to try to evaluate first, is dependent on their ordering in the file. So do we have any other questions about the proper Jedi example? Well, we can also try and see if Anakin Blue is a proper Jedi, right? I mean, that's kind of stupid, but we can try to figure it out. So we can say, is a proper Jedi Anakin Blue? Huh? Oh, per. Okay, there we go. Period. And it says false, okay, which is fine. I mean, that's exactly what we expect. We can also say who owns what, okay? You can say X, Y, both being variables. Then it will tell you everything that it knows about ownership in this entire universe. Who owns what, right? So if you do it like this, you will say, then it will say, Luke owns shuffle A. Okay, that's true. We know that. Luke owns screwdriver A. Yep, we know that. Luke owns Anakin Blue. We also know that. It will tell you everything. Now, because there's no everything that we put into here meets these requirements, it does not say it is false anymore. You can also ask who owns a specific item. So you can say owns, and then this time we do not say who, and then we just say who owns Anakin Blue. And then it will reply and say, Luke does. So it's kind of cool, right? I mean, you can kind of ask questions and change the variables within a predicate and just say, okay, these are the constraints. Who would meet these constraints? And tell me. And it will go explore and do all the reasoning, quote unquote reasoning for you. Is that okay? So now the next question is, what about negations? Occasionally we need to say not something, right? So how does Prolog handle negation? Negation is a little bit interesting. Disjunction is semicolon, by the way. But negation is the one that is important, that is kind of interesting. Negation is tricky because there's no such operator as a not, okay? There's something like not, but it's not really exactly the same way as not. It is known as backslash plus, okay? It is kind of like a not, but it's not really the not that we are familiar with. So now we'll specify another predicate here, which is cis tolerant. X is cis tolerant only if, okay? Y is a cis. Now remember, X is on the left-hand side, but Y is only on the right-hand side. Okay, so Y is existential. And we cannot confirm that X disagrees with Y. So backslash plus is kind of not, but it is a not in the sense of we cannot confirm. Anything that cannot be confirmed is considered false. So let me say that one more time, okay? We'll say it in different ways so that you can kind of look at it from different perspectives. So let's read it from the right-hand side first and then get back to the left-hand side. So the right-hand side says, if you can find me a cis, okay, Y, and you can show me that there's no confirmation that X disagrees with Y, then X is known to be cis tolerant. Yep.
Is there nothing that cannot be confirmed that could be true?
Well, okay, so that depends on how you look at things, right? So in a normal setting, when you're arguing with someone, okay, things that cannot be confirmed true is just not confirmed true, but it is not necessarily false either. Is that okay? I mean, that's a very common, argument that people use in theology, politics, and whatnot, okay? Can you say that something that cannot be confirmed true to be false? The answer is no, not really. Okay, not confirmed true is simply that, not confirmed true. But in Prolog, if you cannot confirm something to be true, then it is false. Okay? So let's go ahead and incorporate this into our rules and kind of play with a few different Jedis and see who is cis tolerant and who is not. Okay? So we get back to here, get out of the Prolog engine, and go back and try to edit the file a little bit more. So now we have to specify a few additional predicates. So we have to first identify who the cis are, right? All we have to do is to look at my t-shirt. There are 3 examples right there, right? Okay, so we got Cedius. Okay. Who else is here? Darth Vader, of course. Vader is a Sith. Who's the other guy? I cannot remember his name. Maul. How do you spell it? M-A-W? Huh? M-A-U. Okay, Maul. L. Maul. Okay. As in being mauled by a bear. Yes. Okay. Okay. And then we can specify disagreements. Okay. In order to be cis tolerant, someone doesn't have to be a Jedi this time, right? Someone has to be not known to be disagreeing with at least one Sith. Okay. So which Jedi is not disagreeing with all the Siths? I suppose you can say Anakin, back in, when before he became a Sith and he was still a Jedi, he was kind of tolerant of what Cedius had to say, even though he didn't really know who Cedius was at the time. So we'll use that as an example. Okay, so we'll say disagree with, disagree with. So we'll say, oh, we don't have Anakin here. Huh? Oh, we got Vader, that's right. Okay, so we can say Vader disagrees with, say that one more time? I didn't quite catch.
Sorry, I was just asking. So for disagree, yeah, you put everybody that's not.
Yep. Well, you have to explicitly state all the disagreements. If you do not state a particular disagreement, then implicitly it is not disagreeing, which is agreeing. Okay, so Vader disagrees with Maul. Disagree with Vader disagrees with we'll pick one more. Not Cedius, with himself. There we go. I mean, that's okay. I mean, there's nothing wrong with disagreeing with yourself. And then we'll have someone who disagrees with all three Siths. Okay, so I'm getting a little lazy here. Bing, bing, bing. Okay, and then we'll substitute Vader with Luke A. And then we'll change the other portion here. So Luke disagrees with Vader, and he also disagrees with Cedius. Huh? Huh? Oh, Luke, yes, that's right. Okay. I'll tell you why it's Luke A. Because that's my son. I'm not kidding. Luke Aoyang? Yeah, that's my son. I always tease him too, especially when other people are looking. It's like, Luke, I am your father. And of course, as a kid, he does not like that much. And by the way, Leia is also my daughter. And very interestingly, they are very much like their character in the movie. Luke is really laid back. My son is actually kind of laid back like Luke. It's like, yeah, we got a war going on, good versus bad. They'll join me and fight to protect and save the universe. And Luke was going like, no, I just want to go back to the farm and fix robots, right? It's only until he went back to the farm, it's like, oh, there's nothing here anymore. I guess I'll join you. I'll just kind of go with you and go somewhere. Yeah, my son is kind of like that too. So now we can say Sith tolerant. Okay, so X is Sith tolerant only if, okay, remember how we read the colon dash, is a Sith, find me a Sith, Y, and it is not confirmed that, okay, I just need to check whether the parentheses are needed. So it is not confirmed, disagree with, X disagrees with Y is not confirmed. Because if that is not confirmed, then implicitly we know that X agrees with Y, and then we cannot say then we can say X is Sith tolerant, because there's no confirmation of the disagreement. So are we doing okay so far with this? Okay. So now we can run prologue again, read Star Wars, and then we ask the question, who is Sith tolerant? And the answer may surprise you. No one. Did I make a mistake here? Or did I have a typo, a spelling mistake?
Check for like one specific person.
Does the space after the /+ make a difference?
I
Is it white space sensitive?
I don't think so. We'll give it a try. I'm guessing that it's something that's a little bit more trivial. Probably has to do with the syntax. Okay, so y is a cisp, and x is not confirmed that x disagrees with y. So this should give me a whole bunch of answers, including the shuffle. Okay, let's think about that. Is the shuffle A cisp tolerant?
Yes.
Well, let's check it. Okay. Okay, Vader is a cisp. Okay, that's fine. Okay, we confirmed that when we wrote it here. Okay, so Vader is a cisp, and then we ask, can we confirm that shuffle A disagrees with Vader? We cannot confirm that. So shuffle A disagree with Vader is now false because we cannot confirm it. It is false, and then not false is true. So that's why the shuffle A as X actually meets this requirement. Should have. So it could be the backslash plus cannot handle a white space. I really don't think that is the case. I might have made some other mistakes. Huh?
Is the slash the right slash?
Pretty sure that's the right slash.
Does the spacing between rules matter?
Huh?
Does the spacing between rules matter?
No. No, the spacing should not matter. All right, well, we'll give that a try. And then we ask the same thing, cisp tolerant. It says nothing is. Okay, well, we can ask it, specifically, shuffle A. It is true. Oh, okay, whenever it has negation, it cannot find all the answers. Yep. Yep, because it doesn't want to go through every single atom in the universe to figure that out. Okay, but the two things that we are concerned about would be Vader, right? Is Vader cisp tolerant? The answer is yes.
Could you go through like all of the Jedi? Is that possible?
I don't think so.
So like do is the Jedi within that and then do X?
You will have to specify a new rule to combine the two, I think. But we can try that. We can try one more first before we do that. Luke Skywalker is not cisp tolerant, so that is correct. Because Luke Skywalker disagrees with all known Siths. Confirmed, right?
Going off like what he said, could you like in the question say give it another question in the question?
So we can try that. So is a Jedi X and
Like in the parentheses.
no?
But the things that go in the parentheses are atoms or variables, and the things like the predicates or transitive is true or false.
Yep. You keep saying Yoda. Leia. Okay, so Leia and Yoda are both Sith tolerant Jedis, which is fine because we did not explicitly state that they disagree with all known Siths.
What meant when if you put cis tolerant and in place of X you put is a Jedi X in the parentheses of cis tolerant? Is that
You cannot do that because whatever that goes into this place has to be an atom. Yep.
Why did Vader return true and false?
Why would Vader return false? Return true?
True and false.
The true is the answer to Vader being Sith tolerant. The false is basically saying I'm not going to go any further to try to look for other things. Yep.
For the not provable thing, can you like explicitly say a specific atom in a predicate is not provable, or do you have to use it with something that's like quantified? Like could you be like Anakin's not Sith tolerant is not provable?
Anakin is not Sith tolerant.
Yeah, like in the rule file, could you do like slash plus Sith tolerant Anakin?
Oh, okay, I see what you mean. Like that? Okay.
So like do that?
Yep.
Close it evaluate? I mean, like stating it as a rule, though, not to like evaluate.
It should be Lucas, but
Oh,
it's still even if it's
yep, there you go.
But did it try to evaluate that, or did it read that in as a rule?
It is only reading as a question. You cannot specify new rules on the fly.
I'm asking in the file, can you explicitly say as a rule that that's the case?
Oh, yes, you can.
Okay.
So you can definitely do it that way. So you can, so in a rule, you can, in addition to rules that have variables, you can just say that, cis tolerant and give it a particular atom. So you can say Dooku, right? Is that how you spell Dooku?
I think it's OO.
D-O-O, Dooku? Okay. It's good to have Star Trek fans Star Wars fans in the class.
Slash plus.
So we can do that, yes.
What I mean with the slash plus, though.
Huh?
With the slash plus is what I'm talking about.
Oh, with a slash plus. Oh no, you cannot confirm with a slash plus as a rule. That won't work.
So it only works with formulas that are quantified?
Yep.
Okay.
Yep. Because it's an operator. Slash plus is an operator that can only appear on the right hand side of the only if.
So you really can't ever state, like, this predicate's always false, except for in a quantified formula.
Correct.
It's weird.
Yep.
You can just not put it on there.
Yep.
And it won't be.
Anything that is not confirmed is automatically false.
And sometimes you want to explicitly say negations.
You cannot do that in Prolog.
Never jump in the pool, stuff like that, you know?
You can always twist it in a way to express the same thing, but it's not. You cannot express something that is not true. It only allows you to specify. Remember, every single rule is a conditional statement. Is a conditional statement that is true. The conditional statement itself is true. So everything that ends with just a period is the same thing as only if true. So you can't really confirm something is false. Just that. So do we have any other questions about this example? Yep.
earlier when you had a variable in one of the statements, it returned false even though we knew everything was true. So if everything is true, it's not going to go in and display everything that is true. It's going to just display.
So the one time that the variable doesn't work is when we try to look for everything that is cis tolerant. That didn't work because of the use of the negation here. When you have a negation, then it doesn't work because the negation involves confirming the lack of something. Any other questions? So in this case, if I already state that Dooku is cis tolerant, I can now have additional rules and say that cis disagrees with all the, Dooku disagrees with all the existing cis, and it would still say that Dooku is cis tolerant, because when you ask is Dooku cis tolerant, it will evaluate all the rules of the same name from top to bottom. And because it finds that Dooku is cis tolerant to begin with, it doesn't even bother to try the second rule. So you can override something just by stating, okay, this is true. There's no particular reason. It is just true. So you can do it that way too. Do we have any other questions about Prolog? No other questions? I can already tell you your homework assignment here with Prolog has to do with ancestry. So this is a perfect opportunity for you to enter your genealogy tree thingy. Okay? And if you are one of those people, who are concerned about, who are my ancestors, and using that to find your, fourth cousin, fifth cousin, sixth cousin, and so on, this may be a good opportunity to kind of dig it up, put in the names, and then try to figure out, who your cousins are. Does anyone do that in this class? like genealogy study? Huh?
Very, very recently.
Okay. So did you discover new people who are related to you that you didn't know before?
I didn't. My stepfather did for his family.
Okay. Yeah, I have a family friend who has been doing this for a while, and he found that along his lineage there were a lot of bottlenecks. Like many offsprings die and only one get to carry on the gene, and then there's another case like that. So they had a few kind of bottlenecks. So it was difficult for him to find relatives because there's a lot of pruning of that tree, so to speak. So that drove him, that gave him even more motivation to go even earlier, because he wanted to find other people who are related to him. So his immediate family obviously are related, but it's difficult for him to find other people who are related. So he's finding all kinds of people all over the states who are related to him through the genealogy study. So you already know that ancestry is going to be in your next homework assignment. So if you can somehow find out if you're interested, okay, if you're not interested, go look up some fictional stuff, and you can represent fictional ancestry as well if you want to. Which show has the most ancestry entries?
Just go with like some kind of classical mythology.
Soap opera.
Huh?
Just go with like a classical mythology, like Greek mythology.
Oh,
Oh, okay, there we go. Yep. So what we'll do in that homework assignment is we're going to express ancestry as a recursive relationship. Because if you know that X is the parent of Y and Y is the ancestor of Z, then X is an ancestor of Z as well. It's a transitive relation. So that's going to be where it's going to be, that's how it's going to be done. But we also want to be able to express what is a first cousin, second cousin, third cousin, and so on. So you might want to think about that a little bit, because first cousin, second cousin, and third cousins, and so on. Those are not as easy to express as ancestry, because now you have a more strict requirement of not just ancestry, but direct ancestry. So there are more strict requirements to make that happen. So I just want you guys to think about it at the back of your head, because that's where the homework assignment is heading. All right. So I'll see you guys on Monday. Have a nice weekend. And don't forget the current homework assignment, which is tracing Dijkstra's algorithm.